Hello, welcome back. The purpose of this video is to review something we did in class, which is to go over Milestone 3, which is due in week 12, this coming Sunday. So part 1, 3 deliverables here. Part 1, use a UML class diagram to model your inventory class. I'm going to leave that up to you. I've posted excellent videos on how to write UML to LoudCloud. We reviewed them a couple of times in class, so do that on your own. What I'll show in C# today is something very similar to part 2 and part 3. Also dip into milestone 4 a bit too toward the end. So we're going to add a new inventory. We're not going to do inventory manager. I don't want to hit the nail directly on the head. I'm going to hit the nail pretty much on the head, but not directly on the head. So we're going to add a new item, remove an item, restock. I don't think I'll do that. Display the items and search for the items. So we'll do all of those things in terms of a C# DLL. And then the test driver, of course, a driver that uses the DLL. View the video previous to this one on how to create a C# DLL for a review of that topic. So I have this human resources DLL or project expressed in terms of a DLL with two classes in it, employee and employee manager. So this is essentially my item class, or the what I'm going to show for the a reasonable proximity of the item class that you need to do for your milestone project. So I have these properties here, C# properties, gets and sets, and then the toString with the last name and first name. Pretty much the employee class or your item class is a data-only class. At least that's the way I see it. So that happens a lot, this data-only class. The real action in terms of code takes place in the employee manager, and we'll review that next. But this is, if you essentially replace this employee with item, you have a very close approximation of what your item class should look like, with properties of your own design, at least 5 properties, remember. So here we are in the other part of the DLL, the employee manager. So we had the employee, data-only class. Now we have the employee manager where the action takes place. So the heart of the employee manager here, in the namespace human resources, is this private list of employee. And this is really what carries the employees and what carries it. I saw some work in Milestone 2 where some students had this being in this class being inherited from the list. I don't really think that's appropriate. That's inheritance, and that would expose all of the list to your client code. So this is a has a relationship, not a is a relationship. So in terms even of your UML diagrams, you need to diagram this as a has a relationship. With a has a relationship, we can selectively choose what to expose about our list. So let's look at the list methods. We have the constructor. Again, you recognize the constructor as a method that doesn't have a return type, so there's no even expression of a void there because return type is not possible. It has the same name as the name of the class, and its job is to set up the object for first use, and here it does. It establishes an empty list of employee. Here we have the method add, so we can add an employee, and remove. I express this in terms of an index to remove. So I want to return this employee, the employee that has been removed also. So I go to the employee's index, save that employee in return code here, or return RC. I use RC for my return names. It stands for return code. And then I call remove at index. Notice that there's no, I don't think it's required. I don't do any checking here for the index is a valid index. I just assume that it is. Not good practice for industrial code, but I think good enough for the milestone. Not industrial strength though. And then I have this populate method. I think you need something similar to this as well for your milestone project. The advantage of this is that you can pre-populate your items with your item classes with pre-made items, and you don't have to say run the application and add a bunch of items before you begin testing your application. So this populate essentially plugs in items into this employee into the employee list using the method add here. So here's our search. Here's search, and that's really probably the most complicated method here. We have a search string here. We'll look at this in a bit. We'll look at the else. But essentially, this says if I'm past a number that's only a number, in other words, I can parse it as a number, then I'll deal with it as a number, and then that's the only thing it's interested in here. So if it doesn't parse as a number, it's going to search the strings. So we're going to lower, and then we lower everywhere. So it's a case-insensitive search. And if you think about the way you use searches in Amazon or Google, you as a human being are expecting case-insensitive searches. So that's what we do here. We lower the search string, and then we lower the last name and the first name. And then if we find matches, we add that object to what we're going to return here. So that's also an empty list of employee. So that's for search strings. If it parses successfully as a number, then we have another branch here, and we're going to go salary here. In this case, if the salary is greater than or equal to what we're looking for in the search pattern, then we add that employee to the returned array as well. Okay. Here's our toString. So this is the toString for the entire class, for the collection. So we iterate over the entire collection of employees, adding a new line to each one of those, and the return code starts out as an empty string here, and then we concatenate the employees we find, and then we return that. Next, we'll look at the test driver. So in our test driver, in main, we instantiate a new employee manager, and then we call populate, so we'll get the pre-built list of employees. We write that out, so we have a toString method. You saw that. That's searching that. Then we do a search string on cat. Then we print out that returns a collection if it's, and then we do a print on that. So that we have a print method here, so that returns a list of employee. Then we print the list of employees. We print the list of employees we found. We do a search string on small b, and then we do a search string on 30,000. That will return salaries greater than or equal to 30,000. So let's run it. And here's our search for cat. Here's our search for b. Here's our search on salary. So that completes most of the milestone. There's a couple of items that you need to write, but that's the heart of it. Next, we'll look at how this looks in a graphical user interface. And that'll be in our next lecture.